Welcome to our tutorial of ProfLearn YouTube channel. In this particular video, we're going to talk about circular motion so that we can see what are the main areas that you must understand for circular motion. So in this case, we are going to look at this concept whereby we shall see what are the different instances that you can talk of circular motion. Some of the instances that involve circular motion, they include a bicycle wheel. When a bicycle wheel is rotating, is displaying a circular motion. A drum of a washing machine, also when a washing machine has been turned on, it's going to display what we call circular motion. A clock ticking, that is an example. So if you consider an object moving from point A to point B, this object as it's moving, it's going to sweep an angle theta at the center. So the rate at which this angle increases is called angular speed. But normally we have what we call linear speed, the rate at which distance changes. So which means the rate at which the angle increases at the center, because when something is rotating, sometimes the angle will be swept quite fast, and then that means the object has a higher angular speed. So the angle or the displacement or the size of the angle swept in this circular path at the center is what we call angular displacement. So if an object moves this particular distance, then we can be able to relate the distance moved and the radius in order to find what we call angular displacement is going to be length of the arc, which is S, divided by the radius here. Now, you need also to understand what we mean by the term radian. A radian is the angle subtended at the center. The angle formed at the center when the arc length is equal to the radius of that particular circular path. So in that case, if you have a radius which is equal to the arc length, S is equal to the radius. If the radius is 5 and the distance moved here is 5, then the angle formed at the center here is termed as 1 radian, a radian. You need to also have in mind that 360 degrees is equal to 2 pi radians, which means that 180 will be pi radians, 90 will be a half of that, and that is going to be a half pi radians, and 45 is pi over 4. But 1 radian will be equivalent to 57.3 degrees. So when you are expected to convert to radians, that's what you have to remember, and we shall be using this to do the conversion. Motion in a circular path, despite the fact that the speed at which the object moves in a circular path is constant, we also realize that the speed keeps on changing direction. So meaning this object is going to be termed as accelerating, even though it's more, yes, an object moving in a circular path is having constant speed, but that speed keeps on changing direction at different instances, so we can be able to say the object is accelerating. And angular displacement can be over time. Angular displacement divided by time gives us what we call angular speed, and angular speed is the change in theta over time. And also for a single revolution, time t is denoted as capital T. For a single revolution, time taken for a complete cycle is called period, or the periodic time. So also, because in a full cycle, in a complete revolution, the angle formed is 2 pi. Then if you take 2 pi divided by the time taken, that is going to give us the angular speed. And that case, we can also say angular speed is equals to 2 pi f, because 1 over t, which can be obtained from here, 1 over t is equals to f. Then we can say angular speed is given by 2 pi f. Just to also touch on key areas, relationship between linear speed, because angular speed is the rate at which the angle changes at the center. But if you have angular speed and you have the radius, then you can be able to tell what is the linear speed. Linear speed is equals to radius times the angular speed. So the larger the radius, the larger the linear speeds, meaning that we can say linear speed is directly proportional to the radius of the circular path. And in that case, we are going to see that for the two particles A and B, which are moving in the same circular path, what is the same is the angular displacement. Angular speed is the same because both of them are going to sweep the same value of the angle at the center. You need to remember that the SI units for linear speed is meters per second, but the SI units for angular speed is radian per second. You need also to understand the formula for centripetal acceleration, and the formula for centripetal acceleration is v squared, linear speed squared over the radius of that circular path. But also it can be given as radius times omega squared, which is the angular speed squared. So don't forget that omega is 2 pi over t or 2 pi f. So you can be able to proceed like that. Centripetal force, we need to define it as the constant force that is always directed to the center, which keeps an object to move in a circular path. And that centripetal force is provided by different quantities. For instance, if you've tied a string and you are whirling it round like that, then the centripetal force, this is what I'm just saying. If you have an object tied in one end like that, and then you move it like that in a vertical circle, horizontal circle, then we are going to say that centripetal force is going to be provided by the tension that is acting here. But also if a car is negotiating a corner, centripetal force is provided by the frictional force between the wheels and the road. If a plane is banking and it's negotiating a corner, when a plane is banking, then the one of the components of lift force is going to be providing the centripetal force. So you're going to realize that different instances are going to provide this centripetal force. So that is the introduction and the basic concept that you need to know for circular motion. And then we shall talk about, check the link in the description, where we have discussed about conical pendulum and also motion in vertical circles, so that you can be able to see how we need to address that. If you're new to Proflan YouTube channel, consider subscribing so that anytime we are going to upload more tutorials, you'll be notified. Also check our Patreon page, where you can be able to access the PDFs that I usually present in Proflan YouTube channel. See you in the next tutorial.